Yo, what up? Hello? Hello? Is this thing on? How's it going, CTBDJC? How do you? How do? Alright. I'll get a couple things open while I wait for some folks to show up before I get started on the schematic stuff. I got some code to test. Well, not really test, I don't think, but let's see. Make this situated. How's everyone doing today? Good, I hope. Alright, and let's see. Install this new version. And let's see. Let's get the here's the ID. Every time. Copy link. That one right there. Doo-doo-doo. And then D for dev, TTY, ACM. I got 3? Okay. And let's see if this works. Yay! Alright, cool. And whee! Let's get some tunes going. Alright, cool. Yeah, I went through and I added a attack D flag to specify the device on the on Linux, the serial device. And what else did I do? I don't know. I changed some stuff. Oh yeah, I fixed a bug, fixed an error. But that's okay. Alright, let's get back to this thing. What the hell was I doing last time? I was probing around at this transformer, trying to fill in the rest of this circuit over here, which is this stuff, I think. Yeah, we were trying to make sense out of this stuff over here. And then I also went back and set up some new layers, one for the actual VSS, or the actual ground layer, because that one was kind of mixed with VDD, I think. This yellow, yeah. So I have that split out into its own thing now, so we can keep track of those a bit easier, because VDD and ground are not the same thing, apparently. This chip has multiple pins. It's got one for ground and one for VDD. Or VGG, sorry. Which reminds me, I want to... Try using the bus feature for this. All these pins over here. D1, D2, D3, D4. Or I can just label them. Honestly, I could come back through here and clean that up later, but this is probably a better opportunity to do it before it starts getting even worse. And this is this whole row of transistors up here, right? This one? Or is it this one? Honestly, I can't remember. Oh well. Yeah, so I think I wanted to probe this thing a little bit more on the board. This, well, box. Literal black box. Which I think is a transformer. And I think it's being used to get the voltage to where it needs to be for the VFDs. I was doing a little bit of reading, so maybe we can try to figure out like what if it is a transformer. Maybe we can try to figure out what the windings are. So yeah, these pins right here. So these all share continuity, these three right here. So that could be a winding. This first pin shares continuity with the second pin, so that could be a winding. And this second pin, or this third pin shares continuity with this fourth pin. So that could be a winding, and then these two bottom pins share continuity as well. Interesting. Maybe I want to power it on again and probe to see if I can find the voltages, or maybe we can measure resistance across these and see if they actually have any resistance. So these two are shared, right? Let's see. 0.4 ohms. Okay, nothing across that one. Nothing across that one. Okay, as you'd expect. So what about this second one and that one? 0.7 ohms. Okay. That one's 1 ohm. 1.8. Okay. And that's 0.5. Is the lowest this first one up here? 0.4. Yeah, so there's high resistance between this one and that one, but lower between the first and the second over here. So these could all be part of the same output winding, I guess? But multiple wraps in. I truly don't know. Where's my scratch paper? I could just write it on the back of this. Let's see. So we've got, what is it? 4 pins. What is 5 pins? Did I test this one right here? I didn't test this one at all, did I? Goofy. Okay, so these three share continuity. They share continuity as well, that's interesting. What is the resistance between this middle one and that one? Wow, 3 ohms. Okay. Interesting. Interesting. Why is that interesting? I don't know. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then a pin right here. Let's just say these are 1, 1, 1, and 1. And then what? These two are okay. 2, 2. And then I think these are, make sure that they're not actually alright. And then what was this one with? This one was with 1, wasn't it? No, wait. This one with those 3. Okay, so this one is with 2. 2. Okay. And then I guess we can measure the resistance between these and map those out to see which one should be the, I guess, further along in the windings. I think. Oh, I wish these things wouldn't get so twisted. So, like say this one for instance. Wait, was it this one? No. Let's just try this one. These two right here. Gives me 0.7 or 0.6 ohms, right? And then the first pin in that one gives me 0.6. So is this about the same? So these are all 0.6 ohms. Right, if I measure that to that. No? So 0.8 between these two. And then between these two and that one, it's 0.6. And then let's measure these up here. These are all part of the same group, right? Oh, the 3. 3 from the top. Gives me 1.6. 2.3. Okay. Let's check that again. Yeah, 1.6. That's 1.6. 2.4. Okay. Not the greatest diagram, I know. .2. And then what about these between each other? But I don't know if this really tells me much other than like it's the distance between these, like how much copper is between these points. Then I'm assuming I have to get out a calculator at some point. Oh man, if only I had a working calculator. So it's 1.2. Is this also 1.2? Yeah. Alright. Most convoluted diagram ever. But I think that helps me narrow down which of these all like kind of share the same winding. Yeah, so I've got 4 windings, it seems like. Actually, let me see if I can power this up. We'll connect these jumper leads because those are necessary to basically flip the power switch. And this is positive. Let me double check and make sure my bench supply is set to the correct voltage. Yep, 6 volts. Okay. So we've got positive to positive. And then negative to negative. Like so. All of our junk is connected. Turn that back on. And I can see 0.3 amps. 0.03, sorry. Running through it right now. And let's see if we can measure the voltage running through this. Now that we know kind of like what the coils are supposed to be doing, I guess. Alright, and so I'll probably want to probe this to ground, I guess. Let's see. Is that our 6 volts? Okay, so this is our... I think the 6 volts is going to be our input. Alright, so I get 7 volts between that, right? Negative 7 volts between that. And this might be where I need to hook up the scope again. Oops. That connected. Actually, it might be easier to, oh, no, it's fine. Okay, so what are we gonna do with... I guess just go poke these again. See what they show up as. Move it down a little bit because these are going to get... Oh, you guys can't see that, can you? I wonder if I need to test it compared to VGG. This, is it VCC or VGG? Is it VGG? It's VGG. Let me test this really quick. I check the voltage between here and here. Gives me -6. What about between that and ground? -7. -1.3. Nothing on that ground plane. Okay. So these might have different grounds, I guess. So then if we test these, if we test this to ground, does this go to 6 volts? Any of these? No? This one goes to 6 volts. What if we test that to VCC? To 4.5. About this one to VCC. Yeah, I still don't know the difference on the board, like why VCC or VGG. Sorry, I keep saying it's VCC. My VGG is a separate trace than the ground. What about this ground over here? .6. Okay. So we could actually change our ground potential to this VGG right here, and then probe this. Goes up to 2.6 volts. X of 3. One's 6 volts. The other day when I was reading this, I was getting like 30 volts was the output. And what about if I do this over the ground pin? Not directly to the battery negative, but the ground plane. $80 millivolts. Huh. Okay. Well, I don't think I'm learning anything new probing this for another time around, so let's just dive back into tracing out the schematic, and then maybe we'll make more sense of it then. And at least now we know, we have a kind of a diagram for how the windings are on this transformer. At least I'm still under the impression that's what it is a transformer, right? Alright, let's see. Let me go grab my drink real quick, 1 second. Alright, so I guess we can go ahead and group all of these together, right? Because these are all, well, they're not on the same, I mean, they are on the same winding, but they're not the same resistance. So maybe we don't group these as like their own thing. No matter. Let's go back over here and start filling this out some more. I believe this was this section right over here where we had our polarized capacitors. And what are we doing? Should number these. Alright, so this guy, right? The JE850U. This guy, JE850U. That base pin comes out to this thing right here. Now how does it get up here to the Schottky terminal or Schottky diode? Oops. Okay. Oh, through here. Comes all the way over here, blah 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 blah. And then Schottky's into the transformer. Yeah, okay. This Schottky goes all the way over into the transformer. Can I label these? Should I label them? Hmm. Could also, oops, could also just bring this around over here, like so, and then we can bring this dude, actually move this whole sucker over. Is it CT8? I think. Wait, is this the right way around? Okay, I gotta number these properly. So... green? No. Ew. Yeah, I don't know, man. Just do that color. Purple. Purple ones. And... Okay, so this is, let's make sure that we don't have to redo some stuff over here. So this all comes from the side with the transistors, which is this side. So this side needs to be 1, 2, 3, 4, 5. Oops. That is not the right color. Where did you get that? What? Yeah, I got a 3D printer. It's a really old Ender 3, like original V1 or V2, I think. But I've modded it, upgraded it over the years, so it is definitely not stock. I don't have a CNC, not yet. I would like to get one, but alright. So we got those numbered, that should help us out. Hey, what's up, Purple? How are you doing? Oh, you're not that late. I haven't really dug super deep into this transformer yet. I did some probing and measured the continuity between these pins. And so these pins are actually, there's a couple different groups. And I have a feeling that they probably share like the same winding. So like for instance, pins 6, 7, and 8. Those are all on the same winding. Or at least share continuity. And then there's a degree of resistance difference between the different pins. So I still think we're dealing with a transformer. I just don't really know anything about it. Still. I also tested the voltage on these pins against the VGG and then the ground as well. And this kind of gave different results. So I have a feeling there's some of these pins are floating on a different ground plane. Oh yeah, all the time. I do that all the time. Hey Patrick. How are you? Always talking about them beans. Okay, so where are these dudes going? Let's get back to these capacitors now that I have these pins labeled on the transformer-ish thingy. Here you can beans. You can print beans. So this is all on the transistor side of this doohickey, which is all this stuff. I think I've got all this nailed. Let's go to pin 1, 2, 3. And then, I guess let's do pin 4 and 5. What are these going to? We can do that. That's probably a better way to chase all this down rather than go through all this rat's nest. We can figure out what all these pins go to. We'll just map out this whole section. This black box will be our anchor. So pin 4 looks like it's going to this transistor right here. Let's see. We may have to probe. Continuity test. Which one is it? Pin 4? This one. Okay, so it's going to the collector on this transistor, which is the JE850U over there. I already have that? I don't think I have that. Because I only had pins 1 through 3 mapped over here, pin 4. Oh, see, I have it going back to pin 3. Should actually be going back to pin 4. Which I guess I could do this way now. Yeah, actually, I think I want to come in here and redo these. Which sucks, but I think it's better because now I know that these are kind of like windings on different, with different amounts of loops or different amounts of turns. Maybe I don't want to do that. Because I know that these three, 1 through 3, are kind of all in the same thing. I can go in and edit this, I think. This, CT850. Do this. Delete that. Right? And then, what else do we have? This thing. How do I make a line? Give me a line. There. That's really weird. There are no rules. And then these two guys are winding as well. So like that. I know that's fucking weird. Wait, no. This one, pin 11 goes to all these dudes too. That's very confusing. How do I want to do this? Because I guess technically it's like a 2 primaries and 2 secondaries, right? Because if these are a loop and these are a loop, and then these 3 are pin 11, 1, 2, and 3, and pin 4, 5, and 10 are all intertwined, then that makes it 2 and 2, I think. Is that even a thing? I guess it's just got 2 windings. It's got a primary winding and a secondary winding, and the primary has like X number of outputs, and the secondary has X number of outputs. Or maybe one of these is the primary, and then the rest of these are all secondaries. I don't know. I'll just leave it like that for now. Come on. Hello? Do not count as a single part anymore? That's weird. There we go. I know, confusing, but it'll do for now. At least now we can see visually that, hey, these are separate. Now let's go back into here. Let's go to this 1226 guy, which is this dude over here. This is our collector. Set center pin. This dude goes to a lot of things. Okay, so if I remember, he kind of squirrels up here and then goes underneath and goes to this transistor, which is a C8 something another. Oh, actually, I got that wrong. It squirrels around. This one is like crazy. It goes all the way over here, comes over here, under here, to here. So that's pretty whack. Maybe I need to erase things that are not part of. That's going to there. Is it? Okay. I can turn it up a little. I'm hesitant to go in here and undo all of the progress that I've made, but I feel like it might be easier to keep track of this stuff. I don't know. I don't think so. Let's come over here. We've got this capacitor. This dude is going to that first pin over here on this guy. And let's just delete this, because I know these are not all the same now. So he's going to there, which goes to 1. And then where else does 1 go? Is that it? Okay. Now let's do number 2. Number 2 is I need to see if number 2 actually touches this trace right here. It kind of looks like they share. But that could just be on the top of the board. I wouldn't think that they do, because when I was probing continuity, it's these top 2 that shared continuity, but not these 2. Those 2 do. Yeah, so 2 and 3 shouldn't be sharing continuity. I think that just goes down somewhere else. Oh, 2 is also going to this capacitor right here. Interesting. Okay, so there's basically a capacitor between these 2. Like that, I think. Yeah, let me rotate it. And then VDD touches the 2 side. Or not VDD, this guy. This guy touches that 2 side. Right? Just the collector. Which is that side of it. Where is VDD coming from? How is that in here? I think. Let's check this. It's all the way over here. Getting that urge again to just erase all this and start over. So this pin is our VDD pin, right? What's that? I see list. Pin 14. Yeah. That's coming from over here. And that's what's going to this, which is our base pin. Right? Or is that our emitter? That is the emitter. Okay, so that goes to our VDD. Take that off. And then this resistor went off over here. Where does that go? And that resistor is going to pin 3 on our windings. And what is that thing? Another capacitor is on that one? Okay, so let's do, oops. Ew. There we go. And maybe we'll do the same thing for this one. Just drag this out over here. Whoa! Oh, wait, I was going to 5, wasn't it? This resistor right here goes over to, oh, pin 3. Normally it's usually after like 4 o'clock Central Standard. Sometime after then, generally. I don't really have a set schedule yet, but usually it's after 4 p.m. This thing goes to 3, right? Kind of ugly, but What else is 3 connected to? Because that looks like... Or no, I'm sorry, that's 2? I don't know, it's kind of hard to see under this black box. This little bit right here. No. Not every day. I'm trying to make it more of a habit. I've mostly been, I've been able to hop on like, Mondays, Tuesdays, Thursdays, and Fridays. Seems to be the case when I have some free time. So I guess pin 4 is just going straight to this dude. So maybe this is, no. I was gonna say maybe this is the primary, because we've got like this transistor right here that seems to be doing some switching. Maybe? I'm not too sure the specifics of why it would be wired the way it is, but let's keep wiring it up. So pin 3 just goes to this, and then also another capacitor, which then goes to VDD, it looks like. So let's get that other capacitor. I think that's this one. And that's connected over... Okay, so it's the one with the resistor coming off of it, this one right here. And it is after the resistor. Maybe we can just move this dude. Whack. Oh, keycad. No, wait. It's after the resistor. Boop, 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 boop. Okay. Alright, there we go. And then this feeds back to VDD. Let me... Collector goes up, base to the right. Come on, just move it. I'm getting into a fight with all the wires. Don't mind me. It was easier to select wires. Nitpicking. I'm nitpicking. Okay. And then this goes back to, let's not forget, this goes back over to here. Okay, cool. Right now I am trying to map out this literal black box up here on the board, which I believe is a transformer. So I'm trying to determine where all of these pins are headed, and I'm basically remapping the schematic from this transformer right here. Because I believe this is what's required to set up the output voltage that drives the vacuum fluorescent displays. And those are supposed to be outputting anywhere from like 15 to 30 volts. Or they should be receiving anywhere from 15 to 30 volts. And in probing the board, I haven't seen that anywhere. And I believe that this part is responsible for it. It might be broken. Not too sure. So that's where I'm at. So I'm trying to reconstruct all of this into KiCad so that I can study it a little bit further and figure out what the heck it's trying to do, and then maybe troubleshoot it a little bit further. Yeah, it could be that the screen doesn't work. Like the tubes are all like kind of blown out or something. Like they could be all fried. But I don't know. I feel like that wouldn't be the case. It could be the IC that's blown out. Like the integrated circuit that actually drives everything. Honestly, I don't know enough about it to check the simple things. So that's kind of where I'm starting from the ground up and learning what all this stuff on the circuit actually means and does, so that I can then try to troubleshoot it. Because I can power it on and I can see that it's pulling amperage from the power supply, but the VFDs don't actually display anything. So the screen doesn't show anything. And I don't know if that's just because the IC isn't fully turning on, even though it's pulling a little bit of power. Maybe there's like a short somewhere, but I don't know if it's the chip's just not turning on. Maybe there's an issue with like the clock signal. Or if it's just the voltage isn't getting boosted up to that voltage required for the VFDs, which I feel like it is, because I haven't measured any higher voltage other than like 6 volts on the board. Well, there's like 7 volts, but that's not enough to drive the VFDs. Oh, these missing golden pins. Yeah, I'm pretty sure that's not the cause. If it is, it would be very, very annoying. It might actually be useful to buy one of these working. I wonder if they've got one on eBay. If I can buy one that's working. And then have something to kind of compare against. Problem is it's kind of a weird one-off. Oh yeah, see, here you go, 140 bucks for a working one. Sheesh. Oh, it's so cool though. Here's a similar one. At least it's got similar VFDs. I think? Or not? Yeah, it looks like it's got similar VFDs. So like I could take something like this, when it's like known working, that's very similar, and try to figure out the internals and what the circuitry's doing on this one, and compare it to the one that I have that's not working. That might be a good option. Oh, that's very sketchy. Does it do it with multiple different wires? Does it with like all of the cables that you plug it in with? Alright, so let's go to pin 5 on this thing. Where is this going? So pin 5, I believe, is going over here to this transistor, which is going to be that A564. And which leg is it going to? The base pin, right? That's what it looks like. So the base pin on this transistor is going to pin 5, which I believe is this guy. Where else is that going? Nowhere? Yeah, I don't know why I had that connected to this other one over here. This base pin right here goes over here to 5 on that sucker. Maybe there are documents that explains how it all works, like on the board, like on a schematic board level, but I have yet to find it. They have some, they have like a user manual on how to use the calculator, which is cool. But I haven't found like an actual like board diagram and description. All right, so the collector on this one is going to, looks like pin 3. Is that pin 3? Okay, I think this is where I need to measure the, not measure, but probe, if I can reach pin 3 from this transistor leg. There's my other wire. Hello? Wow, really? That's as good as you plug in? Like, has no grab. Look at that, that's so loose. What the heck? Wow, that sucks. Is it just that? Oh, it might be this little, jumper wire. Wow, that's really crappy. Try jump wire number 2. Oh yeah, that fits much better. I don't know what that's all about. Okay, so the collector pin on this guy. And then I'm just going to probe continuity. Okay, so those are... Oh yeah, the pin 3 and pin 4 are connected. And they really have that written down. I'm here to repeat and work. It's written down in front of me. So... pin 3 goes to that, and then pin 4 goes to this, and then... Oh, it was 2 and 3 that I needed to test, right? No. Okay, no. It's pin 3 goes to the middle pin on this transistor right here. So the collector goes to pin 3. I guess I could just do it like that. And then this other one, the C828, which is this guy. So I got the emitter going to VDD, which is right here. So this is our base pin. This is going back over towards the Schottky diode, right? Base pin's coming back over here to the Schottky. And then our collector is this middle pin. Where's that sucker going? This one's going to the base pin on that A transistor, the A24. Okay, so these aren't connected. Good. Alright. Okay, so we've double checked that. We have these going to the right pins over here on this side, which is good. Now let's try to get all this junk connected up onto the opposite side. So this all connects up to this side of the transformer. We can come over here to pin 6, 7, 8, 9, and 10. Pin 6 does not actually look like it is connected to... Okay. So pin 6 actually looks like it connects to this whole trace up here at the top, going to all this nonsense. This is going to be our ground. That's a ground. What is that? VGG or ground? That's ground, right? Ground. We've got a ground reference, goes into one of our caps. This is our polarized cap, hits the negative side of that. What was the layout on this though? I don't remember which capacitor this was. I guess it's one of them not hooked up to the rest of the stuff. I guess we can pull this out to 2 resistors, or is that 3? Is that 3 total? Just 2. So we can pull this out to 2 resistors. And this looks like it goes back to the input side of things over here. We have 2 resistors kind of feeding this crap over here. That's not what these are, right? The 3.8 and the 5.6? The 3.3 and the 5.6? No, that's these 2. Okay. So we do have 2 more resistors. And those are going to be connected to pin 6. Right? Correct. Anyway, I want 6, not pin 1. Pin 6. Okay. I'm just going to throw these on there for now. Then the other half of this comes back over to this capacitor, which is connected to ground. Do I have one of these guys connected to ground? I don't think I do. Let's just throw a new one. C, polarized. And we're going to stick this one. Just do positive side right there. Move this up a little bit. you should be able to go into like your fan profile or get some overclocking software and adjust the fan curve. Make it so it's less annoying. That's pretty annoying though. I still need to go in and adjust the fan curve on my CPU pump. Because whenever it starts going crazy, it just goes woo. Alright, so we have our ground there. Our polarized capacitor with the negative side going to ground, positive going to pin 6. Let me just double check that. Yep, that looks correct. And then we also have the positive side of that going to another capacitor. Okay, so this might be where it kind of daisy chains into these other capacitors. I'm just going to delete these for now. Actually, I'll undo that. Because the studio is actually coming to these two capacitors. Let's go back to this guy. This is our JE850U, which is this guy. Hooking up to this capacitor. And that one. We got a hole. Okay. Oh, really? Doesn't support pin control. So this capacitor, it's on the negative side of it. Okay, so this transistor is actually hooking up to the negative side of these capacitors. Like I have so, or at least on that one. And then it's going to, this is the Schottky diode. And then to another negative. Wait, no? Oh yeah, that's going to that weird wire loop. So the base pin coming off of this going to the negative on one capacitor. It's only on that. I don't know why we have that. That guy right there. We'll do this. Move our Schottky boy up. Yeah, so the positive side of this capacitor flows into these two right here, I think. The traces on this are kind of gnarly. They're a little all over the place. They're all squiggly boys. just double checking. So we've got this one. And then that goes to... God, that's so hard to see. And maybe we may just have to start probing some stuff over here. Testing continuity. Okay, so this positive from this capacitor goes to another one. So let's put that one in there. Oops. Where the hell does that go? That goes to another Schottky diode? Yeah, so the negative side of this dude comes over here to the Schottky diode. And then the Schottky diode goes all the way. Oh my gosh. What is that dude? That's another Schottky diode? Are they like facing each other? So this guy, let's start with this one first. This one goes to pin 8 on our transistor. Anything on the other side of that? Or transistor, transformer. We got that going to pin 8. And then goes to VGG, right? Which side of that? The negative side of that goes to VGG. And this Schottky diode goes to 6? 7. That one goes to 7. Yeah, so this Schottky diode goes to 7, and then this one goes to 8. I think we're missing... Yeah, we got that capacitor. Missing this one right here. Alright, so we've got 3. That one's going to ground. That's this one. And we're missing 2 more. We got these two, and then this one and this one. This is actually feeding a resistor network, so maybe we can throw that in there too. It's another custom that we made. I rotate that one like this. Right, we've got so this isn't actually, this capacitor is not actually connected to this at all. It's a separate thing, right? It's not connected to that weird wire. No. Alright, I'm gonna do some continuity testing. Check these capacitor pins. Okay. Alright, so it looks like the negative looks like this negative pin right here next to this pin on this capacitor right here, which then goes and feeds this resistor network. So is that the negative side? I think that's the negative pin. Yes. So let's get our another polarized capacitor in here, and the negative end is going to, where the hell is it? Coming off this second capacitor, right? This guy. One that goes into pin 8. This guy right here. I guess technically that's coming from VGG? No. VGG is over here. The positive end is... oh, so I need the negative end onto... alright, negative end. Positive end goes to VGG? I'm confused. I've confused myself. Alright, so we got this pin coming out of the transistor. And then over here hits the negative pin on this polarized capacitor. Comes in, hits the negative pin on this polarized capacitor. Positive pin out goes to this doohickey, this guy right up here, another capacitor. We get the positive into that one, so positive to positive, positive to positive. Negative side of that goes to VGG. Right, is that VGG? ESS. Wait. No, sorry, that is VGG. And does the positive side go to VSS? Because there's that whole pad up there. Yes, actually. So this follows through and continues to this, which is VSS. So we need to positive 7. We need to move these down like this. And then this can go VGG is on the negative side of this second capacitor. So VGG is actually over here. Oops. Put a sticker label on this one, like that. Now let's get another one come down here, and this one is going to be VSS. Right? Positive pins on these both go to VSS right here. And then VSS also has a Schottky diode coming out of it. So we may need to move this down some. And then put a Schottky on it. Like that. Where that's going, I have no idea. Alright, so now this guy, now that we've got this arranged a little bit better, let's do this guy right here. Positive end is going to that resistor network and to this guy. So, go to that. And then add another polarized capacitor. Oops. Right, I believe that's how that is. Yep, goes and feeds the... oh, that's actually the negative side. Okay. This is the negative side. We'll flip this dude around. Like that. Alright, so this guy, that's the negative side? Yeah, negative side of this is connected to the positive side of that one. So this guy right here, right? Oh wait. Positive side of this one. Alright, so the negative of that capacitor is going to this. Let's ignore this guy for now. Just to not confuse myself even further. So the negative of this one is going to here. And then the positive is going to the output of... sorry, the negative of this one, which is going to VGG. No? the positive of this one should be going to VGG. I think it's supposed to be like that. And 8 billion devices run Java for a reason. I'd imagine there's a reason why people continue to program in it. I could go for some coffee right now, though. Coffee sounds pretty good. I'm getting a little twisted up on these capacitors, though. They are very confusing. Just because they're polarized, I want to make sure that I get them right. So this negative flows over here into the positive right here. This first one. And the negative comes from this transistor right over here. And then positive flows into the negative of... Hold on. It's the negative of this first one. I think that's what's been throwing me off. This guy right here. Because this is the first one. Negative comes over here, goes into the positive, this, then goes into the resistor network. And then on this side of the positive, we have another nope, that's a negative. We have a negative pin? Correct. Where that sucker's going, I have no idea. Alright, now let's go and connect these again. Or double check this. So we've got the positive coming out of this one, going to this one right here, which is the positive on this one. And then the negative goes to ground. Or VGG. Okay, so I do need to flip this back around. Right? And then we have one more. I guess that's what's confusing me. This is VSS. This is VGG. This guy connects to VGG. The negative pin does, right? Yes. And then the positive continues to VSS. I could also number these and it would probably help a little bit better. What color are capacitors? When you think of a capacitor, what color comes into your brain? a nice orange. I don't think we've got very many good orange colors. Ah! Oops. Okay, so let's go ahead and we'll name this one C5. Oops. Yeah, C5. That one is C6. Alright, there we go. I won't get all fucked up on what capacitor is what on my schematic. I mean, I probably still will, but this will help me get less messed up on them. Okay, so we've got C4, C6. And just to double check, C6, this one goes to VGG. Yep, the negative goes to VGG on C6. And then it also goes to a Schottky diode over here. And then to another Schottky diode? What is that? Yeah, to another Schottky diode. That's this guy. Alright, whatever. So that's C6. This guy right here. And then C5 is this one. So the positive of C5 is connected to the negative of C4. Correct. And then the positive of C5 goes to our resistor network. Wait. Oh, I said that wrong, didn't I? The negative of C4. Negative pin of C4 connects to the negative pin of C5. Oh shit, okay. That's actually not going to the resistor network. Okay, so C5's flipped around. See, I flipped C5 around. Because we've got negative going to negative, right? Yes, and then the positive, I think. Okay, I gotta probe this again. Where the hell does that go? Oh shit, okay, I see. This is going all over the place. Okay, so this pin, this one goes to the resistor network, that's the negative. And then this positive goes like all the way down to the socket. Over here? Yeah, right here. Alright, you guys can't see that, my bad. It goes on the back side, so... This is the negative pin of C5 going to the resistor network. Let's just get that real quick. That goes to the resistor network. And then this pin, this dude right here, goes to this thing right here. Which goes Lord knows where. Interesting. Also looks like it carries on through to here, which we can test. Where was it? Yeah, right there. Which is that solo pin all by itself. Right below 8. Yeah, the one that my mouse was on. That one. Okay. So C5 goes to the resistor network 1. Okay, let's double check. C6 goes to VGG. Negative goes to VGG, right? Correct. And also goes to Schottky, and then that goes to pin 8, and another Schottky. Okay, and then let's do C7. So let's stick C7. C7 is going to ground, so that's this one, right? C7. And where else is C7 connected at? Positive of C4 and C6, right? Alright, I think I'm gonna take a break real quick, get some more drink, go to the bathroom. I make myself a cup of coffee. So I will be back in probably about 10 minutes or so. I'll leave you guys with the breadboard. Okie dokie, be right back. Okie dokie, I'm back. Wowee! Okay. I got a nice cup of coffee. Alright. Oh, cool, and I left my multimeter on, like usual. Do you want to kill 9-volt batteries? This is how you kill 9-volt batteries. Pro tip, you can use occlupenids to store your jumper cables, small wires or whatever. Okay. So we're still filling out these capacitors down here. We've got this doohickey C8. We can name this one C8. We need to get C7 down here connected to all this junk. We need to just... Oops. Ew. It means you chat a lot. You're the only one chatting. Everybody else is just watching. You're sitting on the throne currently. Alright, so C7 is this one. Right here. We need to have the negative side of that connected to ground. Positive side connects to C4 and C6, the positive terminals of C4 and C6. Maybe I should do this number. Ah! No, get out of here. No, is it the negative side of C7? Or no, it's the positive side, right? It's connected to C4. Okay. Which means that you need to come down here. Oh, goodness gracious. Wham. Get rid of that. Okay. Then I can move this over some. Oop. And that. Wait, that comes after... I may have messed that up. This comes after here. Or is that C4? No, that's the negative side of C4. What about C5? That also means the negative side of C5. Wait. No, the negative side of C5 goes to this resistor network, which is this. But this we can put over here. No, because the potential point of VSS is on the other side of C6. Oh, okay. I see. Like that. This used to be a mess, but I think the more I stare at it and the more I move around the parts and clean things up, the more it makes sense. Or at least makes less sense. Okay, so this Schottky is this one on that. And we've got the line on this side of the doohickey. Then it goes to VSS. Okay, so let's cross-reference this. So capacitor C7, the positive goes to VSS, and then there's some resistors on the other side of it, right? Let's see. I think it's the top traces on this board. Yes. So all of this trace, these traces, all of these are all on VSS. Okay. Which makes this make sense. Or we're cleaning it up. Okay, we still have C8 to deal with. And the other end of the Schottky diode. Let's do C6. Positive side of that is going to VSS. The negative side goes to VGG. Positive side is VSS. Negative side goes to VGG. And then two Schottky diodes. This one. And then that one, right? Correct. Okay. We're just double checking our work. Alright. And then this, I don't know if we need... Okay, so that first Schottky diode, C6, which is this one, right there, goes to pin 8 on our black box, right there. Okay, cool. So then let's look at pin 7. Wait, pin 6? Yeah, pin 6. Pin 6 coming off of this thing should go to 2 resistors, VSS, and then our chain of capacitors. So, let's see. Pin 6 comes up through here. Goes to the positive of C7, right? Which also means that it is on the same line with these, which is also VSS? Wait. No, wait. This doesn't need to go to VSS. Oh, no, wait, it does. Okay. Yeah. This is all VSS. I wonder if we can do some paint bucketing. Hello, kitty cat. What's up? You know, that's a good question. It would probably take, I think, maybe about the same amount of time if you're reverse engineering the schematic all the way down to every single component versus making like a calculator from straight parts, like transistors with no microcontroller. I guess it depends on what your pre-existing knowledge level is, right? You're more comfortable with dealing or with like making up circuits and putting together individual parts from the ground up versus taking them down and following traces like I'm doing. I think someone mentioned a while ago it's called forward engineering. I heard that that was a term, forward engineering. Okay, so those are all in the same one. I want to try to paint bucket this. My bucket. F for fill tool. Ah! Okay. Oh, shoot. We're gonna have to go down to our board top. We want to add... See, I feel like it'd probably be easier to just trace it with a brush or something. Eh? Why is it not drawing? Not in erase mode, am I? What have I done? Hello? Is Krita just not doing brush stuff anymore? Have you given up on me, Krita? What the heck? I'm so confused. What is wrong with you? What did I do? Do I have something selected? Is that what it is? Oh my god. I had something selected. Holy crap. Alright. Isn't that goofy? Oh, this is gonna be awful. Doop 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 doop. So this is all VSS. This. Wop 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 wop. Gross. But it does the trick. And we'll promptly hide it. Wait a minute. Where is that at? ESS 28? Oh. This one. Tetris minigame. Does it have an Easter egg in it? Alright, so these two resistors. These suckers, where do they go? We can deal with those. We can deal with this capacitor, C8. Deal with the other side of this Schottky diode. What's this one? This one's going to... Which one is that? this one, coming off of C4, the negative of C4 and C7. Right? C4. So is this in the wrong spot? I mean, this definitely is. This Schottky diode goes to pin 9. I don't have that one, right? So, boop-a-doop-doop. Goes over here, but I think we need to move him over to... here. And we can disconnect him from here. This goes to the negative of C4, right? Which is on this side. Which I guess is coming out of that thing. Yeah, so come over here. Okay. Comes out of that thing. And then I think we need to flip this because on the board, the actual part does have a polarity to it. Where the hell am I looking at? This guy. Okay, so they're all facing the same direction, but it needs to be with the line going towards the mystery box, the transformer thingamabobber, this thing. There we go. Boop. Actually, it can, it'd be better to move these. Right? I don't know if that's better or not. Ah! Wait, pin 7 is this green one. That one's coming off of ground. Just straight up coming off of ground. So this doesn't go over here. C7 goes to ground. I guess we could just copy this. Boop. And doop. Oh no. Somebody put Java on my breadboard. Alright, let's double check 8. 8 goes to this one. Is that another diode? Another Schottky diode over there? Oh, oh, whoa, 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 whoa. Haven't I done that one? Didn't I do this one? Hold it from over here. I had that on, I think there's a layer. Help! I'm buried in my layers. Okay, whatever. We'll just do it anyway. Okay, so 8, right? That's 8. I kind of want to add a, some lines. Okay, now I can see those better. You know what that means, purple? That means it's refactor time. Maybe. Okay, those are a lot easier to see now. From the top layer. And I guess the bottom layer too. But where was I? I'm trying to figure out these pin 8. Pin 8's got some freaky stuff going on. Pin 8 goes to a Schottky diode. No wait, yes, pin 8 goes to a Schottky diode. This one. Goes over to VGG. Okay, I have that. What about C6? Does C6 actually connect to VGG? Yeah, it does. Yeah, you know, that's the thing that I haven't quite figured out yet. What's with the scary amount of transistors? I wish I knew more about the actual electrical engineering behind all of it, but I don't know enough about electronics to say, oh yeah, this is what they're doing with all of this just by looking at the arrangement of things on the board. But I believe what these are doing is they're using these transistors to switch the voltage from this circuit up here, the actual driving circuit or the boost circuit that boosts our 6-volt battery voltage into, say, 25 to 30 volts for the vacuum fluorescent display. And because there are 8 individual tubes, 9 I think if you count the E at the very end, yeah, 9 tubes, I believe you've got to have a transistor to switch the current for each tube. That's my theory. I don't know. all of these are coming from, all of these transistors are currently being fed from this resistor network right here, which comes off of the negative side of this circuit, I think. Oh, negative side of this capacitor. I think? No. Yes. The positive side of this one, the negative side of this one, goes into this resistor network, which then feeds all of these transistors, which then go into various pins on this port, which go to the display. And then you've got some more down here. I think this is for like the clock circuit. This might be for the clock circuit, or this might be for the clock circuit. These three pins right, or these two transistors right here. Let me, actually, that's not a bad idea. Let me do regions. Did I spell that wrong? Why does that seem so wrong? No, I don't think it can run Doom. I mean, maybe if I get it to the point where I have individual segment control over the VFDs. No. Probably not. I don't think there's enough information being displayed to do that. Also, I have no idea how this integrated circuit works. So this is, I think, powered in. And power? And power out. Okay, so this is output side. This is input side. Oops. Not filled. Wow, that really wants to go outside of the thing. I've got way too many layers. Do. Yeah, the breadboard can run Doom. Okay, so that's driver input. I don't really need to do this. It's probably just gonna clog up my layers, honestly. Could do that later. Let's do, I want to group these real quick, so I'm not scrolling through them so much. Cool. The hell is this? Oh, I don't want to do that anymore. I changed my mind. BC. I don't remember what that is. Okay. Do a little bit of cleanup. What does that say? Okay. Let's go back over to the capacitors. Okay, so I've got those on their own thingy. C6. Where are those at? What layer are these on? Oh, VDD. Okay. Alright. Whatever, that's fine for now. So, C6, the negative from this one goes to this thing. Got that blue. We're just gonna double up on this one right quick. Wait, no, not right there. Where does C8 go? The positive on C8 goes somewhere. Okay. Goes over here down to 10. And then whatever the hell that is. I think that's just a diode. Right. So C6 goes to VGG. C6 negative goes to VGG. 8 is this one. Also goes to VGG. There's a Schottky diode in the way. And then this other Schottky diode all the way over here on the other side goes to what? It goes to this. Oh, I think I've got just an open this dude right here, right? No, wait. Which one is this? Is this that's the C828? Yeah, so that's C828. Connected to pin 4. Wait, one of these is supposed to be connected to pin 4, right? Where do I see that? Am I just crazy? Oh, this guy. I'm looking for this guy. This is the C828. What the hell is he connected to? He's connected to, is that VDD 14? Okay, so we'll go with the C828 that's connected to VDD. This one. And that is what this connects to? Must be. Like that. Really? Okay. If you say so. Cat, what are you doing? Cat's trying to get in trouble. So that runs all the way back over here to this C828, which also goes to a resistor, right? Correct. That goes to a resistor that's chilling next to it. There should be a resistor over here somewhere. Is that what this is? I feel like, I feel like that's not right. Because there's only one... There's only one Schottky diode over here on this side of the circuit. I think this is the one that I was supposed to be using. But I don't think that works right. Because this... goes to that. Those are all in the same one. Okay. Oh, nice. Yeah, are you using like JET850U or whatever? I was using that earlier today to look at some APKs. Anything? That is right. What is this? This is the base pin from the C828 going to that resistor? And then the emitter does not go to that resistor. I don't know, I have the emitter hooked up to that. Okay. This emitter does not go this way. Wait, which way does it go then? Oh, shoot! That is VDD, right? Let's see. Hello, Kitty. That's the VDD pin straight from the chip. Okay, wait a minute. Yeah, I feel like this might be a little jacked up. I think I want to take this, place it over here, like so. Wait, what did I do? Bruh. Okay. I think it actually needs to be on. Does it need to be on that side? Got this one coming from pin 8. Oh. I think that's what it is. Because coming off of pin 8, we've got this Schottky diode. And then we've got another one going the other direction. And then over here we're connected to C6. And VGG. And VGG. Okay. I think that works, right? Maybe? I don't know. When I'm done, I'll send this to PCBWay and have them print it out. I have my own calculator. Custom version. I was thinking it probably wouldn't be... I don't think it would be too difficult to have everything else the same, where it's all transistors and sockets and diodes and stuff, and all through hole components that you could potentially hand solder. And then instead of using the Texas Instruments integrated circuit, you could put down like a Raspberry Pi or something like that, and then just put some code on the Raspberry Pi that would control all the circuitry to run your own calculator. That was my thought, like, if in the future, if something ever, like, maybe, who knows, maybe this integrated circuit is broken. If that is the case, then I should be able to replace it with a microcontroller that does similar functions and just wire everything up the way that it should be. Right? Alright, these two resistors I still have not figured out, and then C8, let's do the back side of that. C8 goes to pin 10. The negative side goes to a diode and 9. Oops. That is on the negative side of the C8. Wait, what? Do I have these backwards? Oh, no, that's positive. Okay. Gosh. Okay, so the negatives... Yes, on the negative side, though. I have a diode. This goes to, what, 10? What was it, 10? Wait, where is this going? Holy crap. Okay, that's going somewhere, I have no idea. But we have this. C8, and then the negative side goes to this resistor network. Wait, turn that around. What are you doing? Oh, wait a minute. Like that? What the hell is that? Bruh, what? Oh my god, there's so many parts that I haven't even gotten to. Oh, insurmountable. Is the code broken? Oh, the code's broken. Why? Why did my code break? You can also change the speed of it. You do like speed equals, I think what, 50? Boop, 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 boop. Boop, 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 boop. I wonder if I can do, hold on. Oh, I'm gonna get distracted. I believe speed 1 is the standard speed. You increase it to 100 and that slows it down. I think? I can't remember how I wrote the code. You can check out the GitHub though, if you really... Wait, no, I don't have that on the GitHub. Haha! Those are hidden. Hidden secret commands. What is this? So pin 8. coming off of this thing. Goes to a Schottky diode, and then oh my god, I've just been lost on the backside of that thing. Holy crap. Okay, so pin 8. Where are we at? Comes off over here, goes to another Schottky diode, which then flippy dippies with resistors? What the this thing right here. JE850. The pin 8? Yeah. Alright. And then let's do coffee. Alright, so this is doohickey. Blam. Blam. Blammo. Blammo. Let's try something like this. Doop. 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 Right, because we're going through a resistor? No, wait. Doop. Oop. Doop. Doop. Holy shit, are those bridged right there? Oh, they are bridged right there. Wait a minute. Then that means... Boop. Wait a minute. Oh, okay. Yeah. Boop. 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 Cool. Okay, I think that takes care of that. Wow, pin 8 goes crazy. You know what I'm saying? Pin 8 goes crazy. So pin 8 Schottky straight to ground. And then on the top layer, it goes down to another Schottky. So pin 8 There's a Schottky straight to ground. Send this guy up. And this one is a different one, right? Or do I have that on the wrong one? Oh shit, no, it's this guy right here. Okay, so that guy's cool. I need to start labeling diodes. It's getting out of hand. Diodes. Black? Black might do it. Okay. Damn it. Alright, this is another diode, right? Which one is that? That's the new one. That's the new one that I want to do. This is still VGG, right? Yeah. I think it's still VGG. Okay, so we have another diode coming off of VGG over here. We'll take diode 5. You're just hanging out over here all by your lonesome. This guy goes like that, and come over here. And we'll name you diode 5. Bloop. And then diode 5 connects to a resistor, which connects to a resistor, which connects to a weird wire. The strange wire. That would actually be pretty sick. Okay. Do a 5-minute coding adventure. It's a pretty dope idea. I wonder how I could do that. Do I have the... Here, close window. Yeah, jump relay scripts. Open folder. Put it under modules, fun words. No, I think you can do like numbers. Num 3? I don't know if you can do that. If it doesn't even do it for me. Okay, never mind. So like 8-ball right here, we can make it do we get a list of fortunes. JSON of fortunes. No. Fortune cookie. JSON. These might be a little too long. Yeah, I know what you mean by that. I hate it when it's super early in the morning and you've been up all night and you should probably go to sleep, but you don't want to. Okay, we'll try it. We'll try it with these. These, we'll copy that. Come over here, we'll make a new file, paste that in here. And do fortunes.json. Can we, run JSON on the breadboard? Ah. Alright, let's do this. Minicom def ttycm3 import JSON. Ah, we can. Okay, cool. Alright. Cool, so now we can do fortunes equals json.load load strings. Oh no, wait, hold on. Open JSON as f. Oops. J equals f dot read all. I like Arch Linux. That's actually what I use is my daily driver. I have it set up with Wayland and Sway as the window manager. Works pretty well. I like it. Fortunes equals JSON loads. J. I guess we could do date f.read all. There we go. We'll just do that. And I think that should do it. That'll give us fortunes as a JSON string, or as a JSON or array object, blah 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 load string. So then we can come down here and we can do, I think we need random. Import random. I think we could do random selection, right? Random dot. I think it's selection. Hold on. Oh, it's choice, right? Return a random element from a non-empty sequence. Okay. Doop, doop, doop. Choice. We could actually do... Bruh. What happened? Where'd you go? Unminimize? What? Bruh, where did it go? Is it invisible now? What happened? Always on top, no? What the what the hell was that? I hit some crazy key combination that made it disappear on me. Where was I? Oh yeah, so we do a random choice from fortunes. F equals, and then we can actually skip the F equals. We may need to change the size of the, so we'll do OLED J dot OLED print random choice fortunes. And that way, whenever you do 8-ball, it should give you a fortune. And let's make sure that size 0 small scrolling, 1 normal, 2 large. If -1 are omitted, uses the default size set by OLED, defaults to 2. Let's do small scrolling, right? Text size, small scrolling. Alright, is that what it was? Oh, just size, not text size. Black. Okay, so now if I do... go to the jumper list. I'll close out of this for now. And then we're going to mount the disk. I'm going to copy these two things. And it either works or it doesn't. Okay, we'll detach that. And then I like to unplug and plug it back in because there we go. Oh, you OS error note. Oh, I have to probably be very specific about the file path, if that's even possible. Oops. I'm gonna do the Python micro Python REPL, and then I want to import os print os.list here. We're just gonna list. Oops. There we go. Nothing, huh? What about that? Okay, so our path actually needs to be Python scripts modules, right? That's what it needs to be. Okay. Okie dokie. Well, thanks for hanging out, Purple. Hope you have a good sleep. What was the... Alright, whatever. Wait. No. Alright, we will attach the device again. Oh, let's go in here and change this really quick. Python scripts modules fortunes. We could probably even move that out of the modules folder, but whatever. There are no rules. Alright, we will take this back over to... Oh, I already had it. We'll take it back over to here. Stick it right there. And I think we're good to detach it. Oh, geez. Whatever. Alright. Did it work this time? Then we could do 8-ball. 8-ball isn't defined. JFS file object has no attribute. Okay. We're gonna have to get into the weeds with the jumperless file system. Where is it? System functions? No. Oh, here it is. Let's see, I've probably got to read. I wonder if I need to specify how much to read. Read from a file object. No, I think you just do that. JFS open. Okay. Cool. JFS open, blah 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 blah. Oh, I didn't do read anyway. Okay. JFS open, and then you call file.read. Okay. Cool. Alright, that should be better. Third time's the charm, right? Oh, code's not running yet. Sorry. We're making it do, give me a good idea, so now I'm compelled to execute on that. There we go. I did that again, didn't I? Modules. One words. Place all. So now it should JSON loads. It should get all of those. Boop, 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 boop. Disconnect that. Name JFS isn't defined. Okay. Okay. Why do I keep closing it? Oh, it keeps closing itself. I think? Or I'm closing it. Syntax error in JSON. Oh no. It's just one thing after another, isn't it? I mean syntax error in JSON. What? I don't know what the hell it's talking about. Why it doesn't like this. Could just hard code it into the damn Python. Actually, we'll do this. Fortunes.py. And then what we can do is, we don't need it as JSON. That was so stupid. Why did I do that? We don't need JSON, we don't need that. We don't need that. We don't even need that. Can import or from, oops. That should be the same. Alright, if this doesn't work, I'm giving up for now and then going back to reverse engineering. Replace all, then we delete that sucker because we don't want them anymore. Oh no, cat's climbing behind the server rack. Somebody stop her! No errors? No errors? Wow! Function doesn't take keyword arguments. What? What does that mean? Doesn't take it. What? But it says that it does. Bruh. Okay. You gotta be shitting me. Okay, let's quit. How annoying. Alright, whatever. Nice. Okay, so now it gives us some some words of wisdom. I guess it's kind of hard to see, but shoulder the responsibility of one's mistake is character. I guess that meant to say to shoulder. Let's do another. Display the wonderful traits of charm and curiosity. It says scrolling. Do you have to scroll it? Wait a minute. Huh, I don't know. We could deal with it later, but that's working now. Yay! Now I get words of wisdom. I can turn on this again, right? And do 8-ball. A huge fortune at home is not as good as money in use. Wow. Thanks, 8-ball. Cool. Well, that's fun. Now it does that. What was I doing? Labeling diodes? I think I might actually hop off. It's getting pretty late. I gotta feed the cats. And my husband should be home from work pretty soon, so I think we made some good progress. I think we'll label some more diodes tomorrow or something. And figure out the rest of this circuit. It does look better than it did, so that's something, I guess. But yeah, cool. Thanks for hanging out, those of you that are watching. Yeah, if you have any desire to watch some more of this crap that I do, you can check out my channel. I've got more live streams. I've also got a couple dumb videos. And feel free to hop into the Discord and check that out if you want to get updates on when the next live stream is, among other things. So yep, I will leave it at that. Thanks for hanging out. Bye!